Installing a 200 amp subpanel requires careful consideration of electrical codes to ensure safety and compliance. Here's a breakdown of the key aspects. Firstly, subpanel feeder sizing is important. According to NEC 310.15, B16, a subpanel feeder can be sized based on the rating of the overcurrent device protecting the subpanel. In this instance, that's 200 amps if the feeder is within 6 feet of the main service panel. This allows the use of 3/0 copper conductors for the subpanel feeder, given the disconnect is within 6 feet of the main panel. Secondly, grounding conductor sizing is equally important. NEC 250.122 dictates that the grounding conductor must be sized based on the largest ungrounded feeder conductor. As the largest ungrounded feeder conductor is 3/0 copper, a number 4 copper grounding conductor is required. Thirdly, the separation of neutral and grounding conductors is a critical safety measure. NEC 250.28 B mandates that neutral and grounding conductors must be kept separate in the subpanel. It is correct to keep the neutral and ground conductors separated in both the disconnect and the subpanel. Fourthly, disconnect requirements need to be adhered to. NEC 408.33 necessitates a disconnect within sight of and readily accessible from the main service panel. Installing a 200 amp disconnect within 6 inches of the main panel fulfills this requirement. In summary, sizing the feeder based on the 200 amp overcurrent protection at the subpanel is acceptable because the disconnect is within 6 feet of the main panel. The grounding conductor must be sized appropriately for the 3/0 copper conductors, which means a number 4 copper grounding conductor. Maintaining separation of the neutral and ground is crucial, and placing the disconnect within 6 inches of the main panel is necessary for compliance. When planning such an installation, it's vital to consult the applicable electrical codes and regulations for the specific jurisdiction. The National Electrical Code, or NEC, provides comprehensive guidelines for safe and compliant electrical installations. These guidelines cover various aspects of electrical work, including conductor sizing, overcurrent protection, grounding, and equipment installation. To start, consider the ampacity of conductors. The ampacity of a conductor is the maximum current, in amps, that it can carry continuously under specific conditions of use without exceeding its temperature rating. NEC Table 310.15. B16 provides ampacity ratings for various types of conductors based on their size, insulation type, and installation conditions. Selecting the right conductor size is crucial for preventing overheating and ensuring the safe operation of electrical systems. Next, it's crucial to consider overcurrent protection, including circuit breakers and fuses. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits and equipment from overloads and short circuits. These devices interrupt the flow of current when it exceeds a predetermined level, preventing damage to the wiring and equipment. NEC Article 240 provides requirements for overcurrent protection, including the selection and installation of circuit breakers and fuses. Selecting the appropriate size and type of overcurrent protection device is essential for ensuring the safety and reliability of electrical systems. Also, grounding and bonding are critical for electrical safety. Grounding and bonding are essential for providing a low impedance path for fault current to return to the source, tripping the overcurrent protection device and preventing electrical shock hazard. NEC Article 250 provides requirements for grounding and bonding, including the grounding electrode system, equipment grounding conductors, and bonding jumpers. Proper grounding and bonding are necessary for ensuring the safety of people and equipment in electrical systems. Conductor types, such as copper and aluminum, have different properties. Copper conductors are widely used in electrical wiring due to their excellent conductivity, corrosion resistance, and ductility. Aluminum conductors are lighter and less expensive than copper conductors but have lower conductivity and are more susceptible to corrosion. NEC Article 310 provides requirements for conductor types, including the selection of appropriate conductor materials and insulation types for various applications. Selecting the right conductor type is important for ensuring the performance and reliability of electrical systems. Wiring methods such as conduit and cable provide protection and support for electrical conductors. Conduit is a rigid or flexible tube used to enclose and protect electrical conductors. Cable is an assembly of two or more conductors enclosed in a protective jacket. NEC Chapter 3 provides requirements for wiring methods, including the selection and installation of appropriate conduit and cable types for various applications. Selecting the right wiring method is important for ensuring the safety and durability of electrical installations. Boxes and enclosures are used to house electrical connections and protect them from the environment. Boxes and enclosures must be sized appropriately to accommodate the conductors and devices installed within them. NEC Article 314 provides requirements for boxes and enclosures, including the selection and installation of appropriate box and enclosure types for various applications. Proper selection and installation of boxes and enclosures are essential for ensuring the safety and reliability of electrical connections. Finally, it is important to consider voltage drop, which is the decrease in voltage along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. NEC Informative Annex C provides guidelines for calculating voltage drop in electrical circuits. Minimizing voltage drop is important for ensuring the proper operation of electrical equipment. In the scenario described, several factors must be considered to ensure a safe and compliant installation. Firstly, the size of the conductors feeding the 200 amp subpanel must be adequate to carry the load. According to NEC Table 310.15, B16 3/0 copper conductors with a 75°C insulation rating are typically rated for 200 amps. This assumes that the ambient temperature and number of conductors in a raceway do not require ampacity rating. Secondly, the overcurrent protection for the subpanel feeder must be properly sized. A 200 amp circuit breaker or fuse should be installed at the main panel to protect the 3/0 copper conductors feeding the subpanel. This overcurrent protection device must be listed and labeled for use in the specific panel where it is installed. Thirdly, the grounding conductor for the subpanel must be sized according to NEC Table 250.122. For 3/0 copper conductors, a number 4 copper grounding conductor is required. The grounding conductor must be connected to the subpanel's grounding bus into the metal enclosure of the subpanel. Fourthly, the neutral conductor for the subpanel must be sized according to NEC 220.61. The neutral conductor must be large enough to carry the maximum unbalanced load that is likely to occur on the subpanel. In many cases, the neutral conductor can be the same size as the phase conductors, but a load calculation should be performed to verify this. Fifthly, the subpanel must be properly bonded to the metal enclosure of the main panel. This bonding ensures that the metal enclosures of the electrical system are at the same potential, reducing the risk of electric shock. Sixthly, the subpanel must be installed in a location that is readily accessible and free from obstructions. The subpanel must also be protected from physical damage. Seventhly, all electrical work must be performed by qualified personnel who are familiar with the NEC and local electrical codes. Electrical work can be dangerous, and it is important to take precautions to prevent electrical shock and other hazards. Before starting any electrical work, it is important to energize the circuit and verify that it is not energized using a voltage tester. Additionally, personal protective equipment such as rubber gloves and safety glasses should be worn to protect against electrical shock and other injuries. After completing the electrical work, it is important to test the circuit to ensure that it is working properly. This can be done using a multimeter or other testing equipment. If any problems are found, they should be corrected before energizing the circuit. Some other factors to consider for the project are the type of building and its construction materials, which could affect the installation methods and requirements. Different types of buildings, such as residential, commercial, and industrial buildings, have different electrical requirements. The construction materials used in the building, such as wood, concrete, and metal, can also affect the installation methods and requirements. The location of the subpanel, whether indoors or outdoors, can affect the type of enclosure and wiring methods that are required. Outdoor installations typically require weatherproof enclosures and wiring methods to protect the electrical equipment from the elements. The type of loads that will be served by the subpanel, such as lighting, appliances, and motors, can affect the size of the conductors and overcurrent protection that are required. Different types of loads have different current and voltage requirements, which must be taken into account when designing the electrical system. The presence of any special equipment or systems, such as emergency generators or fire alarm systems, can affect the electrical requirements for the building. Special equipment and systems may have additional requirements for grounding, bonding, and overcurrent protection. In addition to the NEC, local electrical codes may also apply to the installation. Local electrical codes may be more stringent than the NEC in some areas, so it is important to be familiar with the local codes before starting any electrical work. An electrician should be consulted to ensure compliance with all applicable codes and regulations before energizing the circuit.